Okay? So density is probably a concept you have already studied in class, in a science class. Density allows us to relate mass and volume to one another. And the reason why density is so useful is it actually enables us to identify substances, because every substance that exists on Earth has a unique density. So the density of gold is different from the density of silver, which is different from the density of iron. So it actually allows us to identify substances if we can first determine their densities. So just as a quick review, the mathematical equation for density is mass divided by volume. Okay, so it's the amount of mass in a specific volume. Now the units for density, they can be varied, but typically what you'll see, the units for mass are grams, the units for volume, typically, most common, are milliliters. So the units for density, you'll often see grams per mil. You might also see grams per liter. You might also see kilograms per liter. Then there is one other kind of quirky unit that you'll see, okay? And that is centimeters cubed. So it's important for you to know that 1 milliliter equals 1 cubic centimeter. So what that tells us is if you make a cube, okay, and each of its sides had a length of 1 centimeter, its volume would be 1 times 1 times 1, because volume of a cube is length times width times height. That would be, its volume would be 1 centimeter cubed, and its volume would also be 1 milliliter. So 1 cubic centimeter is the same thing as 1 milliliter. Okay? So sometimes we'll actually use this equation, density equals mass over volume. I tend to only like to use it when I'm actually solving for density itself. Otherwise, if I'm given density and asked for one of these variables, for mass or for volume, I actually like to use density as a conversion factor. And I'm going to show you in a number of problems just how I do that. Okay, so let's look at the first example. It says, what is the density of a piece of metal if the mass, so I'm solving for density, so I'm going to use my formula. Okay, it tells me my mass is 562 grams. Okay, and it tells me my volume is 14 milliliters. So I'm first going to put my unrounded value here. So my unrounded value that I get is 40 point, I'm going to actually round a little bit, so don't go too crazy. let's say 3. My units are grams per mil, because I divided mass, grams, by milliliters. Okay. Now I need to figure out significant figures. So since I'm dividing, I'm going to be rounding to my fewest number of sig figs. 562 has 3 sig figs. 14 has 2, which means I want my final answer to have 2 sig figs. So I want to keep the 4 and the 0. The 1 does not round the 0 up. So I'm going to end up with 40. Now here's the problem. I want 2 sig figs, but if I just write 40, then that would be 1 significant figure. So what I'm actually going to need to do is put a decimal place so that now I can count from left to right so that the 4 and the 0 are significant. And my units are grams per mil. Okay? And that's my answer. Okay? Let's look at the next practice problem. An object has a mass of 3.15 ounces when it is submerged in a graduated cylinder initially containing 325 mils of water. The water level rises to 442.5 mils. What is its density? So there are 2 different issues I have. The first, the mass I'm given is in ounces. And notice, based on the units for density, I want to get into grams. So I'm going to use the conversion factors I gave you here to figure out the mass. So I'm going to do that in 1 second. I also need to discuss the fact that it tells me I've got a graduated cylinder. It initially has a volume of 325.2 mils of water. Well, why does that matter? Well, they're not directly telling me what the volume of my object is. Instead, what it's saying is, hey, if I take this object and I drop it into water, then that will cause the water level to rise to 442.5. So without the object, it was 325.2. Now it's 442.5. So what I can do is if I take the difference between those 2 volumes, right, that'll tell me the actual volume of the object. 325.2 is the volume of just water. it rose to 442.5 as soon as you added the object. So logic tells you that that must be the volume of the object itself. And so the volume of the object itself is going to be 117.3, if I subtract moles. So now I've got my volume, so I'm good there. Now I've got to figure out my mass. Okay, I'm in ounces. I want to get into grams because that's the unit for density that I want for mass. So notice the two conversion factors allows me to get out of ounces, first into pounds. Okay, now I'm in pounds. I don't want to stay in pounds. Now I can get into grams. Okay, so in one pound has 16 ounces. 1 pound has 454 grams. So I'm going to take 3.15, divide by 16, and then multiply by 454. And what I end up getting is 89.38125. Now notice I'm not rounding this value. When you're dealing with a multi-step problem like this one, where you're having to multiply, subtract everything, do not round until the very end, okay? And then I will round, okay? So now I can actually calculate my density. I know my mass is 89.38125, okay? My volume is 117.3 mils. And so unrounded, this value is 0.761988. Okay, let's figure out sig figs. So this is where it gets a little bit complicated, so you got to really pay attention with sig figs. For my mass, remember the conversion factors don't count towards sig figs, so I'm just looking at 315. So that has 3 sig figs. Because remember, the last thing I'm doing is dividing, so I need to round based on the fewest number of sig figs. So my answer up top should have 3 sig figs. I didn't round it to 3 sig figs because I didn't want to over round it. Then to find my volume, I subtracted. Remember, the rule for subtraction is you use the fewest number of decimal places. Okay? Well, 442.5 and 325.2 both have 1 decimal place. So this is actually how it should have been rounded. So this number should have and does have a total of 4 significant figures. Okay. Do you see how that's complicated? You're actually subtracting here. You have to keep it in here, right, for your volume. You have to keep in mind what the number of sig figs should be, but not round it until the very end. So that keeping track, I know we'll struggle with it a little bit, but I'll make sure to ask questions if it doesn't make sense to you. So I need to round my final answer to 3 sig figs. So what I get is 0.762, and my units are grams per mil. Okay.
All right, so in the first 2 example problems, you were asked to solve for density. What if I don't ask you to solve for density, and instead I give you your density and ask you to solve for either mass or volume? So the next 3 practice problems are going to have us using the density formula to solve for our unknown. So if the density of a substance is 0.56 mils, so that is my density, what is the volume? I'm solving for volume. If the mass is 3.5 grams, so that is my mass. So I'm going to be using the same formula, density equals mass over volume. But now, instead of solving for density like I did before, I'm now going to be solving for my volume. So 0.56 is my density, equals my mass, which is 3.5 grams, divided by my volume. And I'm going to keep reminding people, but the number 1 mistake that students make in these problems is the math, not the chemistry. So here, my volume's on the bottom, and so a lot of people just want to take 0.56 and multiply by 3.5, but that's not how this works because volume's in the bottom. So I'm going to cross multiply. This is how you would solve for V. So cross multiplying, all you do is you have 2 fractions on either side of an equal sign, and you're just going to multiply across. So I'm going to multiply 3.5 by 1. That's going to equal 0.56 times V. So I'm going to write this out. So I have 0.56 V equals 3.5, because 3.5 times 1 is 3.5. And then to solve for V, all you have to do, since 0.56 is being multiplied by V, you just do the opposite of that, which is dividing. So I'm going to divide both sides by 0.56, and that will give me my answer. So I'm going to take my calculator, and I've got 3.5, and I'm going to divide by 0.56, and I get my volume equals 6.25. When you look at 0.56, because I'm just multiplying and dividing, I'm basing my answer, my rounding, on sig figs. So 0.56 has only 2 sig figs because I'm counting from left to right, so just the 5 and the 6 count. And 3.5 has 2 sig figs as well. So my final answer needs to have the 6 and the 2. I'm going to get rid of the 5, so this is going to become 6.3 units. Remember, density is mass divided by volume. So if you look at the units that I gave you in this problem, you've got grams per milliliter. Well, the units for mass are grams per milliliter are the units for volume. So my mass was in grams, that was given. So my units for my volume will be in milliliters. All right, so what if instead I ask you to solve for a different variable? So in these two practice problems, let's look at example 4 and then example 5. So in example 4, it says if the density of liquid mercury is 13.6 grams per mil, so that is my density. So now I know my density. What is the mass? So I'm solving for my mass, and it's going to be in kilograms, but I'll deal with that at the end of the problem, of 35 milliliters of a sample of mercury. So 35 milliliters, guys. Remember, milliliters is a unit of volume. So I have my volume here. So I'm going to be using my formula, density equals mass over volume. Okay. I know my density. I'm going to plug that in, 13.6. I'm solving for my mass, that's M, and I'm going to divide by my volume, which is 35. Okay, so unlike the previous density problems where all you had to do was take your mass and divide by your volume, now I'm going to be solving for mass. So whenever I see a problem like this, I automatically in my head think I need to cross multiply. So I'm going to put 13.6 over 1, and now I'm going to just cross multiply. So I'm going to do M times 1 equals 13.6 times 35. So M times 1 is M. And then I'm going to take my handy dandy calculator, and I'm going to grab it. I'm going to take 13.6, and I'm going to multiply by 31. So 13.6 times 35, I get 476. That is my mass. Okay, a couple of things that I need to keep in mind. 13.6, because I'm just multiplying in this problem, I'm basing my rounding off of sig figs. So 13.6 has 3 sig figs, and 35 has 2 sig figs. So my final answer needs 2 sig figs. So I'm going to keep the 4 and the 7. The 7 is going to round up to an 8, so 480. And my units for mass are grams. Now I know they're grams because if you look at the density, it's grams per milliliter. Remember, density is mass divided by volume, so the mass units are grams, mass divided by my volume, which is in milliliters. So I'm in grams right now, but notice the question wants me to be in kilograms. So I'm going to do a conversion now because I got to get out of grams and I'm going to get into kilograms. So I'm going to put grams on bottom, and I'm going to put kilograms on the top. When I look at the relationship between grams and kilograms on page 21 of your workbook, I know that 1 kilogram is 10 to the third grams. So I'm going to take in my calculator 480, divide by 10 to the third, and that is 0.48 kilograms. Okay, so that's my answer when I'm solving for mass. What if instead I want you to solve for volume? So if you look at the second example, it says, what is the volume? What volume? So I'm solving for my volume. Will 45.0 grams of an unknown gas occupy? So 45.0 grams, grams are a unit of mass. So that is my mass. If the density of the gas is 2.26 grams per liter, so that is my density. So I'm going to use my formula, density equals mass over volume again. My density is 2.26. My mass here is given to me is 45.0. And now I'm solving for volume. Now, if on the previous problem you just took 13.6 and multiplied both sides by 35, that'll give you the correct answer. But the number one math mistake that I see from students is when they're solving for volume. They'll just randomly multiply 2.26 by 45. You can't do that because volume is in your denominator. So you've got to cross multiply here. There's no exception. So I'm going to take 45 times 1. That's going to equal 2.26 times V. So I get 2.26 V equals 45.0. So now to solve for V, I need to isolate V, which means I need to get rid of 2.26. Since 2.26 is being multiplied by V, the opposite of multiplication is division. So I'm going to divide both sides by 2.26. Divide both sides by 2.26, and that will give me my answer. So I'm going to take 45, and I am going to divide by 2.26, and I get a volume of 19.9115. And look at my original problem, and I am given 45.0 grams, which has 3 sig figs. 2.26 has 3 sig figs, so my final answer needs 1, 2, 3 sig figs. So my answer is 19.9. Now I got to figure out my units. If you look at your density, right, it's grams, which came from mass divided by my volume, and my units for volume here are in liters. So my answer is 19.9 liters. Now, I would love to box off this answer and call it a day, but unfortunately, I need to be in milliliters, and right now I'm in liters. So what I'm going to do is I'm going to go from liters, and I got to get into milliliters. So I'm going to put liters on the bottom, milliliters on the top, and when I look at page 21, I know that 1 milliliter is 10 to the negative third liters. So I'm going to take 19.9 and I'm going to divide by 10 to the negative third, and that gives me 1.9 times 10 to the fourth, when I divide my calculator, milliliters. Okay, oh, sorry, 1.99, my bad, times 10 to the fourth. And that's my answer.